Good morning, everyone. This is Sathish Kumar. My subject name is DC Machines and Transformer. Today topic construction of DC machine. We'll discuss about construction of DC machine. Before going to explain the construction of DC machine, actually what is the direct current machines? The direct current machines are divided into two types. One is the DC generator and as well as the another is the DC motors. So most of the DC machines are similar to AC machines only because the principle will be same, and in case of the DC machines the conversion of energy from one form to the another form is there. Similarly, in case of the AC machines also the conversion of energy from one form to the another form will be there. Means they have AC voltages and current within the limits only. And DC machines have DC outputs just because they have the mechanism converting AC voltages to DC voltages at their terminals by using the some another equipments, that is the commutator. So that is the part of the construction of the DC machine only, and this all mechanism I am calling as a commutator. Therefore, DC machines are also called as a commutating machines we are calling. And DC generators are not common as they used as because the direct current when required is mainly produced by some electronic rectifiers only. And while DC motors are widely used such as automobiles and aircraft and portable electronics in speed control applications, wherever it may be, wherever we have the applications we need, we are using the DC generators and as well as the DC motors. So means mainly the DC machines having divided into two, that is the DC generator and DC motor. So why I am calling the direct current machines here, because of we are giving the DC, that's why this is called as a direct current machines. Now we'll discuss the construction. In construction, for example, I am taking the DC motor. The function of the DC motor is converts the electrical energy to the mechanical energy, and the DC generator's function is converts the electrical energy to the mechanical energy to the electrical energy. So means this conversion process I am calling as a what? Electromechanical energy conversion. That's why a DC machine is an electromechanical energy conversion device you are calling, because it converts mechanical power into electrical power or electrical power into mechanical power. So when output electrical power is DC, it is called as a DC generator. When it converts DC electrical power into mechanical power, it is known as a DC motor. So coming to construction, main construction features are, in case of the DC machine, that is the main thing is the body or magnetic frame or yoke. This is the one part. And pole core and pole shoes, this is the another part. And field or exciting coils, this is the another thing. And the armature core and as well as the armature winding and the commutator and brushes and end housings and bearings, shaft. These all are main parts of the DC machines. We'll discuss each part. So this is the construction feature diagram. You can observe the construction feature diagram also. So what I am saying first is the body or yoke. This is the body or yoke. And the next is the, I am taking here field winding. This is the field winding, and this is the field core, and this is the armature winding, and this is the shaft, and these all are the end housings. These are the end housings. End housing with having the brushes. This is the brushes we have, and two brushes we have, and this is the bearing or pulley, and this is the commutator. I already said AC machines is similar to the DC machines. In case of the AC machines, we are getting the AC output. That AC output we are converting here DC output by using the one device. That device I am taking here, commutator. That is the only difference between the AC machines and DC machines. So this commutator function is converts from AC power to the DC power. So now this is the brush holders and this is the armature core. These all are the main parts of the construction of the DC machine. Now, so you can observe this is also, this is the closed diagram. This is the opened diagram. So this is the yoke of the upper part of the DC machine. And if you are removing this all things, what I am getting here, this is the field poles or field coils I am getting here. Field poles or field coils. And this is the armature coil and armature winding. And this is the commutator. And this is the brushes. This is the shaft. If this is the closed diagram, this is the opened diagram. So now, what is mean by function of the yoke? What is mean by function of the commutator? What is mean by function of the armature coil? What is mean by function of the field coils? We'll discuss now. So first one is the magnetic frame or yoke. This is the magnetic frame or yoke. This magnetic frame or yoke is the outer cylindrical frame. This is the outer cylindrical frame to which main poles and their poles are fixed here. And by means of mechanic machine is fixed to the foundation is called as a yoke here. So what is the purpose of this yoke? This yoke will be provides the mechanical protection to the inner parts of the machine. This yoke is the gives the mechanical protection to the inner parts of the machine. And also it provides the low reluctance path for magnetic flux. That's why this yoke is made up of cast iron for smaller. And this machine hand cast steel or fabricated rolled steel are for larger machine. For smaller machine we are using cast iron. For larger machine we are using cast steel or fabricated rolled steel we are using for larger machines. So this is the yoke. Yoke is the main purpose is it provides the mechanical protection to the inner parts of the DC machine. It is made up of cast iron. Okay. So this is about magnetic frame or yoke. Next, pole core and pole shoe. You can observe this is the closed circuit diagram. So in this have you on the pole core. So like this will be their pole core. This pole core and the pole shoes. This is the pole shoes. This pole core and pole shoes are fixed to the yoke by some bolts. Yoke by some bolts. Means this serves the some advantages is there if you are using the pole core and pole shoes, and also it provides the supports the field coils or are exciting coils. So this will be supports the field coils or exciting coils, and they distributes the magnetic flux on the armature periphery for more uniformly here. That's why this pole core and pole shoes we are using. Pole core we are using. And why we are using the pole shoes? If you are pole shoes having a larger cross-sectional area, means you can observe this is the pole shoes. If you are having the larger cross-sectional area, the reluctance of the magnetic path is reduced. The reluctance of the magnetic path is reduced. So that's why the pole core and pole shoes are made up of laminated steel. Made up of laminated steel assembled by riveting together here under hydraulic pressure. They are using hydraulic pressure to assemble the laminated steel to make pole shoes and pole core. This is about pole shoes and pole core. Next, field or exciting coils. That's why this is called as a field winding also you can call. That is field coils or exciting coils, or this is the field coils. You can observe this yellow color symbol is the field coils. These field coils are placed in the pole core. Okay, pole core carries the field coils. So means these field coils we are also called as exciting coils. That is are used to magnetize the magnetic core. Okay, or pole core. These field coils or exciting coils are used to magnetize the pole core here. And these field coils are made up of enameled copper wire. Enameled copper wire is used to construct the field coils. And when direct current is passed through these coils, means these field coils or this field winding, it sets the magnetic field which will be magnetize the pole core. Which is the magnetize the pole core to the whatever the required flux we need, that the required flux will be exciting here. So this is about field coils or exciting coils and coil. Armature core. Armature core. So armature is a rotating part. So you can observe here, this is the field coils I am telling, or this is the field winding I am saying. So this field winding is constant, but the armature core is the rotating layer. So according to the principle of the DC machine, according to the Faraday's law of electromagnetic induction, whenever a current carrying conductor is placed in the magnetic field, then induced EMF will be produced, we are saying. Means that induced EMF is directly proportional to the rate of change of flux linkage. Means when we need the electromagnetic field, when we will get the electromagnetic field? When one part is rotating, another part is constant. Means if the magnetic field will be rotate or coil will be rotate, then only you are getting the magnetic induced EMF in the coil. So means we are getting the dynamic induced EMF as well as the statically induced EMF. In case of the DC machines, we are getting the dynamically induced EMF. Means dynamically induced EMF is nothing but here armature coil, means coil is rotating, magnetic field will be constant here. So that's why, which is the coil I am taking here? Armature coil I am taking here. So means this armature core is rotating here. Means armature core is a rotating part of the DC machine. Because of reversal of flux takes place, so hysteresis losses will be produced here. And to minimize these losses, we are using silicon steel. We are using silicon steel for the construction of the armature core. For the construction of the armature core. And this rotating armature will be cuts the main magnetic field, or means nothing but is a what? Field magnetic field. Main magnetic field. Therefore, we are getting the induced EMF in the armature core according to the dynamically induced EMF. This induced EMF circulates the eddy currents in the core, which results the eddy current loss in it. So the armature core is laminated to reduce the eddy current losses. Let's say this armature core will be laminated, and armature core will be sarsuda, or armature core is used for it houses the conductors in the slots, and it provides an easy path for the magnetic flux. It provides the easy path for the magnetic flux. That's why we are using the armature core. Okay. Next, armature winding. You can observe this is the armature winding. So, the number of conductors in the form of coil, we discussed the definitions also. So the number of conductors will be formed here. Coil will be placed in the slots. You can observe here. These are the slots. These conductors will be placed in the number of conductors will be placed in the slots here of the armature core, and suitably interconnected are called the winding. These are the interconnected. This coil, this coil, this coil, this coil, this coils all are the interconnected here. So this interconnected I am calling as a what? Armature winding I am telling. So this is the armature winding is made up of copper or aluminum, and this armature winding where conversion of power takes place, that is in case of the generator mechanical power is converted into electrical power, and in case of the motor electrical power is converted into the mechanical power. Okay, so this is about armature winding. Next part, this armature winding is divided into two windings, that is lap winding and as well as the wave winding. Means depending upon the types of interconnection of the armature coils, the windings can be classified here two types, that is the lap winding as well as the wave winding. So we discuss later about the lap winding and wave winding clearly, but lap winding here, the conductors per coils are connected in such a way that number of parallel paths are equal to the number of poles is called as a lap winding. Means, for example, if the machine has P number of poles and Z number of conductors, then there will be P number of parallel paths will be there in case of the lap winding. And each path will have Z by P number of conductors in series. Also, the number of brushes are equal to the number of parallel paths in case of the lap winding. So means out of which half of the brushes will be positive and the remaining will be negative. Okay. And another winding is wave winding. So in case of the wave winding, the conductors are connected here, that they are divided into two parallel paths only. That is, number of parallel paths in case of the wave winding is equal to only 2. Because irrespective of the number of poles, if the machine has Z number of conductors, there will be only 2 parallel paths. That is, each will be having Z by 2 number of conductors connected in series with only 2 brushes in case of the wave winding. So next is the commutator. We discussed already. So AC machine is similar to the DC machine. So coming to commutator, it is the most important part of the DC machine. And the purpose of commutator is it converts the rotating armature conductors to the stationary external circuit through brushes. Means rotating armature conductors means is nothing but we are converting into alternating current or alternating voltage. We are converting into direct current or direct voltage by using this commutator. Means it converts the alternating current induced in the armature conductors into unidirectional current in the external load circuit in the generating action, and it converts the alternating torque into the unidirectional in case of the motor. So you can observe this is the commutator. This is the commutator we are seeing. So this commutator will having the copper segments. These are the copper segments. This commutator having the copper segments, and these copper segments will be adjusted at the end ring. Adjusted at the end ring and adjusted to this shaft also. Adjusted to this shaft also. This is the function of commutator. Next. And commutator, it converts alternating current induced in the armature conductors into unidirectional current in the external load circuit in case of the generating action, and in case of the motoring action, it converts alternating torque into unidirectional torque produced in the armature in motioning action. Okay. Now, this commutator having cylindrical shape, the cylindrical shape, and it is made up of wedge shaped hard drawn copper segments. Wedge shaped hard drawn copper segments. It is made up of for commutator. And these segments are insulated from each other. The segments are insulated from each other by thin sheet of mica. Thin sheet of mica. You can observe here. This is the mica insulation. Okay. And these segments are held together by means of two V-shaped here. You can observe this is a V-shaped. Two V-shaped rings that fit into the V grooves cut into the segments. And each armature coils is connected to this commutator segments. Each armature coil through some riser. This is the riser I am using. Through this riser, each armature coil is connected to this commutator segments. This is about commutator. Next, brushes. And brushes are made up of high grade carbon. They form the connecting link between armature winding and the external circuit. And these brushes are held in particular position around the commutator by brush holders only. You can see here. So this is the end housings. They are attached end main frame here. This end housings attached to the end main frames and supporting the bearings. And the front housing supports the bearing and brush assembly. This is the front brush assembly. And whereas rear housing supports the only bearing. Rear housing. Only bearing. This bearing and brush assembly, whereas rear housing supports the only bearing. Means this is the end housing having the rear housing and front housing. Front housing will be supports the bearings and the brush assembly, whereas rear housing will be supports the only for bearings. So this is the construction of the DC machines. Bearings. Then what is the function of the bearings? The bearings is to reduce the friction between the rotating parts and as well as the stationary part of the DC machine. Because in case of the DC machines, we have rotating parts are there and as well as the stationary parts are there. So means in between these, we are using the bearings. These bearings will be reduce the friction of the rotating and as well as the stationary parts. These are fitted in the end housings only. Generally, these bearings are made up of high carbon steel. High carbon steel. Next is the shaft. Shaft. What is the function of the shaft? The function of the shaft is to transfer the mechanical power to the machine or from the machine. Transfer the mechanical power to the machine or from the machine also the shaft will be used. And this shaft will be made up of milled steel with the maximum braking strength. Maximum braking strength. Because this all the rotating parts are like armature core or commutator or cooling fan, etc. or this shaft only supports. Okay. So these 10 parts of the construction of the DC machine. So we'll see overall diagram now. This is, you can see here, This is the overall diagram, cross-sectional view of DC machine here. So this is the brushes, and this is the brush axis. This is the yoke or upper part of the DC machine. These are the field windings. These are the armature. This is the armature, and this is the armature conductor, and this is the field poles. This is the one north and south pole. This is the field poles, and this is the main field axis, and another is the field. This is the pole core and pole shoes. This is the cross-sectional view of the DC machine. Okay, so this is about construction of the DC machine. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.